All right, so that is where we're at today. We are doing answering questions from the homework for chapter 12. Let's see if we can't connect to my screen here. Uh, hmm. All right, so who has questions? Anybody have any questions about homework problems so far? Only 8 questions, man. What a nice assignment.
I'm starting with number 6.
Number 6. 6. Ah, this is the one that has the code issue. And I did look at this. I couldn't find anything initially wrong with the code, so let's see if we can get the answer right here. Excuse me. Okay, so here's a problem we've got. We've got a hose going into a fountain that sprays water up to some particular height, like this, 12 meters in my case. And they want to know what radius should this fountain nozzle have in order to reach the desired height. So we're looking for the radius here, R. We know that the flow rate, Q, here is equal to 0.3. And that's 0.3 meters cubed per second, the flow rate. All right, so we can, there's a couple of different ways to do this. Probably the simplest way is to just first try to figure out well, let's see here. Yeah, the first thing to do, I think, is to try to figure out what equation we're going to use. Now, not necessarily what equation, but what information we're going to need to know. So as far as this goes, we could actually do it using kinematics and use the flow and the radius to calculate the velocity equaling some particular height. And you could do it using kinematics, but we might as well just use Bernoulli's equation, because Bernoulli's equation says that you have 1/2 rho v squared plus, so let's start with pressure. Pressure 1 plus 1/2 rho v1 squared plus rho gh1 has to equal pressure 2 plus 1/2 rho v2 squared plus rho gh2. And what we want to do is we want to use the point where the point here will be right when it's coming out will be our point 1, our first position, and up here will be point 2. And for 12 meters of height, there's almost no difference in the pressure outside in the air. So that means that pressure 1 and pressure 2 will be equal, and those two will go away. And then in the rest of the equation, the density of the fluid is all the same because it's all water, so that all goes away. And we're left with this very simple equation, V1 squared plus GH. Well, let's call H down here equal to 0. So that means that this is going to be 0. So this just becomes V1 squared on the left side. And that has to equal 1/2 V2 squared. Well, at the top, V2 is equal to 0 when it gets to the top, right? So that becomes 0 at the top, and it's less, and then it's going to be equal to G times H2, which we know is our 12 meters in my particular case. So that's great. Well, how does this?
On the other side, isn't it half V1 squared?
Yes, thank you. 1/2 V1 squared. Well, then you say, well, how does this help us? Because we don't know V1 squared, and we don't know V1 squared. We do know H, but we're not trying to find V1 squared. We're trying to find R. Well, it turns out that R is related to V1 squared. Well, how is it related? We know that Q, the flow rate, is related to the pipe that something is flowing through. Well, how is that related? We have to go back to our book because I can't remember the equation. I could probably figure it out. Well, we could just figure it out by drawing it, I suppose, instead of going back to the book, and then we figure it out that way. So remember last time we were talking about this pipe here that has this radius R, and it has some distance or some length of water L, and that travels that distance. So what you get here is you get pi R squared to get the area of this section here, and then multiply by L, and that gives you the volume. And Q is equal to volume per time. So you divide by time here and you divide by time here. So this is volume, not velocity. But this length divided by time is velocity. So Q is also equal to pi R squared times pi R squared times the velocity, right? So this is equal to pi R squared times the velocity. So we can actually solve this for velocity. That means velocity equals Q over pi R squared. Then we replace that in this equation here. So I'm going to actually multiply both sides by 2 just to simplify my life a little bit. And then I have to square this thing, so it ends up being Q squared over pi squared R to the 4th. And that's V1 squared equals 2GH. Then I'm solving for R now, so I multiply both sides by R to the 4th, divide everything by 2GH, and I get this equation. Taking the 4th root of everything on the left side, you will get the answer that looks like this. R is going to equal the 4th root of Q squared over 2 GH pi squared. And we know everything in there now. Now, let's calculate it and see if it gives us the right answer. My flow happens to be 0.3, so I put 0.3 squared in there. And then I divide by 2. I divide by 9.8. I divide by H, which is 12. And I divide by pi squared. And I get an answer of 0.00003881. And I'm going to take 2 square roots of that, which is equivalent to a 4th root, right? So I take the square root of it twice, should be good. And I get 0.07 meters for that. So I'm going to go ahead and plug that in and see if it works. 0.0789 meters. Actually, I don't even have to plug it in, but I can just check the key. Whoop, it doesn't like that. It says 0 meters. must be the that must be the error. The error is in the way the answer is formatted. But that should give you the correct answer. Let me go take a look and see if I can fix that error really quick. Which number was that again?
6.
Number 6. So the answer format is significant figures. Oh, they did square root. I think it should be the 4th root. Square root q over 3. Oh, but they did square root of q over pi. And I don't think that's quite correct. Answer box number pressing. Yeah, I think that they need to do another square root here, so I'm going to do that. So they did square root. What was my answer? My answer was the 4th root of q squared over pi squared 2gh, right? So they need to do a square root of their 2gh inside of this answer. So I will do that. And that, I think, should fix it. Save that. Done. Let's go back to chapter 12. Number 7, you say? 6. My answers have not changed since my last submit answer. But I want to see the key here. Retry this question below. Still doesn't like my answer, and I can't, for some reason, I can't. There we go. Show me the answers already. There we go. Such questions. Why won't it show me the answer? That's really dumb. Let's look at it a different way here. Here we go. Okay. Still won't show me the key. Why won't it show me the key? What is wrong with this dumb thing? I should be able to see the key and see what answer they're expecting, but it's not letting me see it. Valuing the code in this question, syntax error. Oh, I see. I can see what's wrong with it, I think, at this point. Chapter 12 again. Settings. 6. Code. Okay, let me try this. 2 square root of the square root inch box. I am pulling my hair out to try to figure this out. What's going on? So that's there. This is here. Oh, I do see what the problem is. Here we go. There we go. Save. Let's try it one more time. I found a coding error that I had missed before for sure. Oh goodness, it has even more errors now. That's great. Expect exactly 1, 2 given on my, yeah. I'm very close to getting the code right. I can feel it. Bear with me just a little bit longer. I think I know what I did wrong. I think I fixed the code in one way and broke it in another way. And if I'm right about what I did wrong, let's see. So I can't do that apparently. Ay, ay, ay. Ah, here's another mistake in the code. Goodness, there's mistakes everywhere. Well, there's less mistakes now. That's good. Four, I really don't like what I did on line. What's done on line 4? Two, 5, 1 pass. Code for at least 2 expected. Now I'm going to try this one more time, and if it fails, then I'm just going to remove the question from the assignment. But hopefully I won't fail. All right. I see. Storage here. That needs that. Okay, this goes to nothing. Okay, now we're getting there. That's very good. I got the code working. There's still one small error that I need to fix just in the math, but the code is working, which is very good. So let me go and fix that one little math issue. You guys could be taking a coding class right now if you were seeing my screen. Maybe I should show my screen to everybody so you can learn how to code. All right, specific discourage. Q. So we had, this is Q over, I can't remember what our answer was. Can anybody read off the formula that we had for me?
It's the quarter root of Q squared over
2GH pi squared. 4th root of 2GH pi squared. Is that right?
the quarter root of Q squared over.
Okay. Looks like I got it correct, but I must have different numbers now. Yeah, because now it has different numbers. So if I plug in the numbers now, from this, it's 0.5 now for Q. So I get 0.5 squared, which is going to give me a slightly bigger number. So it should be working now. Hooray for me. 0.5 squared divided by 2 times 9.8 times 8.5. Oh, sorry, that's not right.
0.5 squared divided by 2 divided by 9.8. My height is now 8.5 divided by 3. Divided by enter. And then I take the square root of that twice. Yeah, it works. Ta-da! All right.
I still got mine wrong.
Okay, so the formula being, let me put this back on now that I'm done coding.
Oh, I have the formula written down. I don't know what I did wrong.
Okay, so this is a lot of stuff to enter into your calculator. The way that I entered it into the calculator is I did everything that was under the fourth root first. So I took the q squared, I divided it by 2, I divided by 9.8, I divided by my height, I divided it by pi twice, because pi squared, right? And then I got a number. And then I took the square root of that number, and then I took the square root of that number, and I got the answer. And I think that was the easiest way for me to type it in the calculator. There's a lot of other ways to do it. And if you have a calculator where you can put in parentheses and all kinds of things, you can do that too. I prefer not to try to enter in parentheses when I'm doing calculations. So when I typed it in my calculator, I did q squared divided by 2 divided by g divided by h divided by pi again for pi squared. And then I took the square root of that answer, and then I took the square root of that answer, and it gave me the correct answer. Does that make sense?
Yeah.
All right.
I still got the same answer. And
Same
it doesn't
answer?
look it. Yeah.
Okay, let me check your answer here. Let me see what it's supposed to be. Did you give it three significant figures?
Yeah.
Okay, let's check here. Numbers. Okay, so you have 0.5 and 8 meters. You should be getting something very close to what I got.
Yeah.
So, and I got 0.111, so yours should be 0.11 something. And I've got, so 0.5, I'm gonna do the calculation real quick. 0.5 x squared. So I'm doing 0.5 squared, dividing by 2, dividing by 9.8, dividing by your h, which is 8. And then I'm gonna divide by pi twice. Whoops, I divided by 10 times pi on accident. That means I need to multiply by 10. And that gives me the number 0.000161,709. Then I'm going to take the square root of that number. And then I'm going to take the square root of that number again. And that gives me 0.1127. So I got the correct number there.
Am I typing in the wrong number?
You might be typing in a wrong number at some point. It should be 0.5 squared divided by 2 divided by 9.8 divided by your height, which is 8, then divide by 3.14. Then
You're not actually dividing by pi.
I'm not dividing by pi, I'm just dividing by 3.14, but it won't make any difference. And then I
Okay.
divided by pi again, because you're actually dividing by pi squared. So I divided by pi again. And then I took the square root of that answer, and then I took the square root of that answer again. And it gave me 0.1127.
Okay, I wasn't dividing by pi twice. That's what I did wrong.
Okay, well, there you go. So it should be 0.113 for you. All right. Man, that was
the fix of it, fixing the thing that I actually fixed in the code was simple, but it was hard to figure it out, hard to find it. I kept missing it. All right. What other questions do we have? That you have any other problems? You have questions you want to ask about?
Number 2.
Number 2. You actually have number 2 correct, actually. You just didn't put in enough significant figures. It just wants 3. So I can give you, let's see, how many times have you done this? Just one?
No, all of them.
Okay. Let me check the. So it looks like you got it correct on your last try there. Is it taking away points for different tries?
Yeah.
Okay, I'll adjust your score properly. I can't remember what's. Let me see if I can do this real quick. How do I do this? I'm pretty sure I can do this. Oh, here it is. So, which number was it again? 2? Okay.
Yeah. 2.
Put your scissors back. Those are some sharp scissors, by the way. Thank you.
So I did it.
Do you sharpen them?
No, I don't.
They were sharp. I liked it. Thank you.
Yep. All right. Okay. So I corrected that for you, and it.
What's that?
Sorry, I'm talking to a student. No noise. So I corrected it for you, and you're good to go.
Okay, thank you.
Yep.
And then I also think I screwed up number 4.
Number 4. Let's take a look here. Need to go back to viewing as the instructor. How do I do that? Look. There we go. Okay. So number 4 is here, and let's see. How many times have you tried that one? Just once?
Just once, yeah.
Okay. So yeah, let's take a look at this one and see how this one is done. Let me share my screen again here. How do I get to my shared screen? Somehow, here we go. All right, so number 4, we have an outdoor faucet connecting to a garden hose. And so here's our faucet, a little handle on it. We're going to connect it to a 3/4 inch garden hose so that the radius here will be, or the diameter rather, will be 3/4, which means the radius equals 3/8, and 3/8 of an inch is 0.375 inches. It's giving us water at a rate or a flow rate of 4.9 feet per second. That should be cubic feet per second, I think. Well, since it says feet per second, maybe we ought to say that it's actually feet per second, which would be not the flow rate, that would be the velocity. Okay. So this would be the velocity here at 1. This would be the radius at 1. And then he splits it into 3 different lines like this. And these ones have a radius of 1/2 inch each, or a diameter of 1/2 inch each.
So that means the radius is 0.25 inches each. But there's 3 of them. So you could say that the radius is actually 3 times 0.25. So we'll make a combined radius R2, call it R2, which are combined with a combined radius of 3 times 0.25. Well, that's not a good way to do it, actually, now that we think about it. But we have, so for we need to calculate the cross-sectional area of one of these hoses and multiply it by 3, essentially. So what are we going to use to figure this out? Well, we know that the flow rate here has to equal the flow rate, or the flow rate here coming into this junction has to equal the total flow rate here. So if we take the flow rate here, call this Q1 and call this Q2, for one of the hoses, that means that Q1 has to equal 3 times Q2. Because this flow has to split into 3 parts equally for these two. And that becomes our continuity equation for this situation. Well, we know 2 things about flow. We know that flow is equal to the cross-sectional area of the hose times the velocity of the hose. And I guess that's really all we need to know. So we know the cross-sectional area of both of these hoses. The cross-sectional area of the first hose is the radius squared times pi. So for Q1 is equal to area 1 times velocity 1, and we know velocity 1. Velocity 1 they give to us. So area 1 times velocity 1 is going to be 0.375 inches squared times pi. Now you could convert that to meters if you want to. I don't think we'll need to, but because the answer they want is in feet cubed per second. So we don't really want to do anything. We don't want to convert that right now. We don't want to convert it at all into meters. We want to leave it in inches and convert it to feet, actually. So here's our flow area. And then the velocity, of course, is the 4.9 feet per second that they give us. So we have 4.9 feet per second. Important to put your units in here so that you can sort out your units at the end. And that's our flow 1. And we know that flow 1 is equal to 3 times flow 2. And flow 2 is what we want to know. So we use this equation and we solve for flow 2. We put this in for flow 1 on the left side. So on the left side, we get 0.37. And actually, I'm not going to put those numbers in. I'm going to put the formula in. This formula with pi r squared in for area. So we're going to have pi times radius 1 squared in inches times the flow rate Q, no, times the velocity V rather, 1. That's the one that they give us up here. For this one, it was 4.9. And then that has to equal 3 times Q2, which is the thing we want to know. We want to know what Q2 is. So we divide this one by 3 to get our answer. Now, the biggest challenge here is to convert this radius here is going to be in inches squared. The velocity is in feet. So we need to convert the inches squared right here, 0.375 inches squared, into feet squared instead of inches squared. So we need to do a conversion. And that conversion is, I think, one of the more challenging things in this problem. It's just one we haven't done before. So we have 12 inches per foot. So there's 1 foot for every 12 inches. But we are going to be converting inches squared. So we have to square the bottom and the top of this to get feet per inches squared. So 1 squared, foot squared, is equal to 1 over 144. So you get 1 foot squared per 144 inches squared. So that's the conversion we need to use. In my problem, I have to convert
0.375 inches squared into feet squared. So I have to multiply it by 1 over 144 feet squared over inches squared. Then, once I've done that, I'll have a completely new number that's in here. And then I'll have to square that as well, because that 0.375 is squared. So do the conversion, get the number, put it back in here and square it, multiply by pi, multiply by the velocity. That will give you Q1. Then you'll plug that number in. Well, actually, then you'll just divide that number by 3 over here. We already plugged it in. So you do this calculation, pi times the radius squared after you've converted it into feet squared. Then you oh, sorry, I did this wrong. I was thinking this is inches squared. It's not inches squared. Sorry, this is incorrect. We don't need to square our conversion. So our conversion, we're going to be converting 0.375 inches and then squaring it afterwards. I was getting ahead of myself. So we need to just use the regular feet to inches conversion here. So it's 1 foot over 12 inches. So just divide this by 12 to get the number of feet that it is, and then put it in here and square it, or put it in here and square it, either way. And then you're good to go. So you need to convert a 3/8 of an inch into feet, which is going to be a fairly small decimal number in my case, because I had the 3/8. So did you follow all that? Do you want me to go through the steps again, since it's kind of messy, since I made this big mess over here? What do you think, Olivia? Did you follow it, or you want to go over it again?
Yes.
You did follow it? Okay.
No, my computer's not working. Okay, I got the wrong answer still, so apparently I didn't follow that well.
Okay, let's draw the picture again, because there's a lot of things to talk about. We're splitting this thing into 3 hoses, right? We know from the continuity equation that the flow here has to equal the total flow coming out all 3 of these combined. The reason we know that is because there's nowhere for the water to go in between. So if it comes here, it has to go out all 3 of these eventually. So it's going to be equal. It's going to split equally. So we call this Q1. We call this Q2, and Q2 is what they want us to calculate. So we call each one of these Q2. That means there's 3 of them, and that's our first equation. Q1 equals Q2 times 3. That's our first equation. Now, since we're trying to solve for this value, we can actually just go ahead and say that Q2 equals Q1 divided by 3. But we still have to solve for Q1. Well, flow, Q, or Q1 in this case, is equal to the cross-sectional area, so that's area 1, times the distance, or the length of the cross-sectional area, which gives you your volume, so they call it the length, and that's divided by time. And length divided by time is velocity, so it's also equal to area 1, velocity 1. And velocity 1 is the thing that they give us right here, this number right there. So we need to calculate area 1, and for the pipe, it's for whatever pipe it is, you're given the diameter right here. Diameter is 3/4 of an inch. So you have to take your diameter D, this is your D, this is your V. You have to divide it by 2, square it, and multiply by pi to get that area. So that's the pi r squared, and then multiply by V1. However, the D is given in inches, so to convert D into feet, we multiply by, we do D times the conversion from inches to feet, which is 1 over 100 So, not 1/144, 1/12. 1 foot over 12 inches. So we do that conversion first, and then we plug the answer in for D up here. Now I divided it by 2 first, and then I did that, but it doesn't matter which way you do it. You're essentially creating an R in feet and then squaring it, then multiplying by pi, then multiplying by the velocity in feet per second. And that will give you your Q1. Once you're done calculating that, you plug Q1 into this equation over here, this formula, and you calculate Q2. Now, what numbers do you have for your flow or for your velocity and your diameter?
My diameters are all the same, and my velocity is 8.5.
8.5, okay. So let me see if, let's see if I can get something here. So if you have the same diameter as 3/4 of an inch down to 3/8 of an inch, it's 0.375. That's our radius essentially.
Yeah.
That's 3/8. Then I'm going to divide that by 12 to get that in feet. So that's my D in the end become, or my R rather in the end becomes 0.03125 feet. So then I'm going to square that number, square 0.3125, and then I'm going to multiply by pi, and then I'm going to multiply by the velocity, which is, what was it, 8 point what?
8.5.
8.5, and that gives me a flow rate of 0.0261 for a flow rate 1, and then I
And
divide.
we don't divide by 3.
Well, I'm going to divide it by 3 now.
Oh.
So then I divide by 3, and it gives me 0.00868. And that is not, is that correct or no?
No, that's the answer I got, and it doesn't like it.
Okay, let me check.
I put in 0.009. I just rounded to the
Well,
third
it
one.
still wants, but it still wants 3 numbers. So the zeros don't
Okay.
count. So do 0.00869.
Okay, it took that one.
Okay. Now, how many times did you put in that particular answer and didn't get your score? That's the question.
I just got it wrong once.
You got it wrong once. So I can add a partial point back to that when I get back to your homework.
Okay.
Actually, send me a message to remind me to add that point, that it's like 0.05 points, whatever it is. So I don't.
Okay, I can do that.
Okay.
Um,
All right, we got through that one. What time is it? We probably got plenty of time left, I imagine.
Yeah.
Okay, so
I also screwed up number 5.
Okay.
But I don't know, maybe it was just sig figs. Maybe I got the right answer at some point.
do you
'Cause
have
that's what I've been doing wrong on all the other ones too.
You have no more questions? Okay. Well, if you don't have any more questions, you don't have to stay if you don't want to. You can take off, or you can stay and listen to us talk about physics. It's up to you. We won't be doing anything but answering questions on homework today. Just so you know. All right. So number 5, you say.
Yeah.
So in this, if you put in if you put in 3 digits, 3 significant figures, does it give you the correct answer with your present answer?
Let me try it really fast. We would only want 2 on this one, right? Or
No, it'll still want 3 non-zero numbers, unless the zero is in the middle somewhere.
my numbers are 2 meters per second, and 0.38.
Okay. Now, what formula did you use to calculate this flow rate?
I just used the Q equals area times velocity, but I used like pi r squared times velocity.
Times velocity. And what was your diameter of your pipeline again?
The diameter is 0.38.
0.38, and that means your radius is 0.19.
Yes.
So you squared 0.19, multiplied by pi, and multiplied by this velocity, and it was wrong still?
No, my velocity was 2,
All right.
but I assume my sig figs are wrong again. But how many do I need to use?
So just use 3 every time, you should be fine.
Oh, okay. Yeah, okay. I just don't have enough sig figs on all of the ones I did wrong.
Okay. Yeah, so always use 3 with this just to be safe. I even sometimes use 4, but you should always use at least 3 and you should be good. So yeah, any of these that you lost points on just because you didn't put the correct number of significant figures, just send me a note and I'll fix that.
Okay. Okay, I'll go back. Yeah, I'll just send you all the numbers that counted me wrong for that. And then also, number 8 didn't actually let me answer it.
Oh, that's weird.
It just like counted it wrong.
I think that I can reset that for you.
Okay.
Let me go do that really quick. Let's see, number 8, version 1. How do I do that? And it only gives you one chance. Is that what it is?
I don't know. I never actually did it.
Let's see, how do
So I don't know if like my computer just glitched out. But when I like clicked to problem number 8, it had atmospheric pressure and then it was like wrong answer and can't answer again. But I didn't answer that.
let's see. I'm trying to figure out I'm trying to remember how to do this. I know that I'm pretty sure that I can reset it, but I can't seem to figure out where I do that. Details. No. Oh. Delete attempts, make exception, override score. Apparently I can't reset it. I thought I could.
I think you've reset it for us before.
I can reset an entire assignment, but for some reason I can't see that I can reset in a single problem on a single person's. Hold on. Question. Student work on this question, but keep the version. Oh, looks like I can do it. So reopen your homework and see if it allows you to answer that question now. It looks like it should.
Yeah, it says I can now.
Okay, I figured it out. Yay.
Perfect. Okay, I don't have any more questions then.
All right, well, if that is the case, we are done for today. Happy early day. Enjoy the rest of your afternoon and your weekend and everything else. Make sure that you're working on labs if you haven't finished them.
Okay.
And let's see, I actually I have an so here's a question for you all. Would, if I gave you a lab to do, could you do the lab? Could you provide a 2 liter bottle, a drill with different sized drill bits? No. Okay. I can provide those. How about you, Olivia? Could you provide those things?
Yeah, I think so.
So the idea here is, let me show you what this lab is about. I think I've got it on this. Nah, maybe I don't have it on this computer. Let's find out. Okay, let's see. Bernoulli, where is it? I don't seem to have it on this computer, but I could probably find it. Let me try to find it really quick. Bernoulli. Ah, there we go. Okay. This is actually the way that I'm going to provide this for you is, oh, here's a, yeah. I'm not sure if I like this one. I found one that somebody has done. Okay, let me try again here. Bernoulli. Bottle. Oh, I see what they're doing now. Okay. Uh, Okay, I actually am going to send this to you. I'm going to send you a website to that has the instructions for an experiment. This is slightly different than the one that I've done in the past, but it looks like it's fairly well explained, and it looks like a pretty good experiment. I would actually maybe modify it a little bit over time. But the idea here is, let me share my screen again. I can't even tell if I'm sharing my screen again. Sharing my screen at all. Doesn't look like it. So let's share my screen. And so this is the website. It's at maths.org. And this is called Testing Bernoulli. You have to have a 2-liter bottle. Do you have a 2-liter bottle or no? You do. Okay. So in this one, all you need is a 2-liter bottle and just something like a knife or something to just kind of bore a hole in the side. And the idea here with this one is that you're going to fill it with a liquid, and it doesn't have to be colored liquid. They put some food dye in it just to make it easy to see, but it doesn't have to be that. You can just put it up against, a background that's a little darker so that you can see the water in it pretty easily. But the idea is that you're going to let the water out through a hole that's near the bottom. And there's some measurements to take. For example, there's a measurement between the height of the water at the beginning and the hole, and the height of the water partially through the experiment and the hole. So you're always measuring a height above wherever you make that hole. And the water is going to come out sideways from that hole. And you're going to use Bernoulli's equation to calculate the speed of the water coming out the hole. Now, what I would like you to modify this experiment just a little bit. They have you just do one hole and then do your measurements of height several times, and then do calculations. So here's a sample data table where they've taken height at different times. So they're essentially what they're doing is they're actually using a video camera to do this, and you could do that if you want to. So you maybe put a ruler behind it and then take a video of the experiment, and then just stop the video at when the water gets down to a certain level and look at that and the time in the video or something like that. And you could do it that way, or you could actually have a timer going, and at 1 second or 2 seconds or something like this, you could just write down the height and then write down the height. Much easier to do it with a video, just with your phone or whatever, but however you want to do it. So they do this, and they're taking different measurements, and because they know how far it's moved in a certain amount of time, they know how fast the water is moving in the bottle, because you can calculate the velocity from that, and they do that. And they actually make a graph of the height versus the time, and so the slope of this graph would give you that velocity. And you can see that it's not exactly straight, and so it's not exactly a constant velocity. It's pretty close. It's not too bad. Yeah, go ahead and make the graph. You can make it by hand, or you can do it in Excel or something like this. What I want you to do is duplicate this. Now, the only problem with this is they get down to this point and they actually do this. They do some math with some calculus here. You don't have to necessarily worry about the calculus. Whenever they have this dH dt, that just means the change in height over time. So that's just delta H over delta T. So you don't have to do any calculus at all. You just know that that means delta H over delta T, the change in height over the change in time. And so if you go through here and do the same calculations, and there you don't even have to do these calculations. You can just go to the end and say, oh, look, here's the formula at the end. No, you do need to know that they've defined some things in here that's different. So for example, they have this lambda in here. Well, what is lambda? As you go back up through to here, they actually are saying this is for some lambda. So in other words, lambda is just a constant that is in the equation. So in the end, it doesn't. In the end, all that really does is give this
give this formula some form that we can look at. And this actually looks very much like a solution to Bernoulli's equations, actually. So anyway, the point being is that you can actually solve. You can let's see here. You can solve this equation. This part right here is actually your velocity. So this is your this part right here comes out as your velocity, and they're using that right here with their numbers. So they have 2 times g, which is 10 meters per second squared, and then essentially the lambda is a 1 here, and then we have our height, which is 80 meters. So if you had an 80-meter high bottle, you could get it going coming out 40 meters per second. But since you only have like a 2-liter bottle that's only maybe 30 centimeters, or not even that, probably more like 18 centimeters or 16, whatever it is, some number of centimeters, then you get a much smaller speed coming out. But this is something that I think that you could do at home. Then once you've done that with one size hole, I want you to change to a different size hole. I want you to make the hole bigger. Now, when you're making the hole in these bottles, one of the important things is to try to make the hole as clean as possible. I recommend just using a sharp knife with a sharp point and just kind of twisting it very carefully without pushing too hard so you don't push through the bottle. Also, make sure that your hand is out of the way, like hold the bottle up high and make your bottle down low so that you don't slip and cut your hand. Or, put it on the table flat and hold the bottle on one end and cut at the end of it. And you're just going to kind of drill a hole through, bore a hole through. You could also just use a drill if you want to, but try not to push hard so that you don't break the bottle. Just try to drill through, make a small hole to start with, and then do the experiment, then make a bigger hole, significantly bigger, and do the experiment again and take the data again and see how it changes. I'd also like to know if you can predict how it will change before you do the second experiment. So this is the website. I'll send this out to you really quick, and I'll do that through my Open Math, I guess. And let's see here. And that is what we want to try to do for this week. No. All right, so there it is. The link is in the homework, or it'll be sent to you in your messages, and you're ready to go. Have a great weekend. Thank you.